Please welcome Professor Harro von Blottnitz.
Hello to the attendees of the Sectoral Sustainability Conference 2021. I am Harro von Blottnitz, professor at the University of Cape Town, based in the Department of Chemical Engineering. It's a great pleasure to have been invited to present at this conference on our research. The presentation has been prepared together with Tahira Goga, who is a PhD student with me, and this is the pre-recorded version in case the live version does not work out. Circular economy seems to be a new buzz, but those of us who've been in the game for a while know that it is a late manifestation of the idea of sustainable development. And on the right-hand pane, we are showing here some of the key milestones in that journey. To get the laser pointer ready, it will be useful. It takes a moment, right? So some of us go back to the Earth Summit 1992. In fact, one of the research students in our research group at the time managed to go over there, and she's a respected practitioner in business in the finance world these days. 2002, the World Summit for Sustainable Development came to our turf, to Johannesburg. And in many ways, this one was about foregrounding the development in sustainable development. But at the same time, business came out quite strongly, and this is global business through the World Business Council on Sustainable Development, and Shell in particular, with the idea of the triple bottom line, the 3 Ps, planet, people, profit. And so we're seeing a slight tension developing at the time, maybe not, between the environmental sustainability and keeping a foreground on the development agenda. Of course, we were at the time also working to the Millennium Development Goals, which had environment slightly weaker. Then the idea of the green economy started emerging in the late 2010s. In my interpretation, this is when green got some economic teeth, moved out of purely being a matter for the environment departments. And of course, in the last decade, we've seen 2015, the adoption of the Sustainable Development Goals, and about the same time, circular economy starting to become a really important concept. This is not something everybody always agrees on. And here's a quote I really like from researchers at the Stockholm Environment Institute. The global transition has begun. A planetary society will take shape over the coming decades, but its outcome is in question. And indeed, it's been in question. The visual here, of course, shows us the kind of pushback against this agenda that countries from time to time see and experience. And the other white gentleman on this picture, and apologies for having 2 white gentlemen, but they seem to dominate our discourse often. But this final work from David Attenborough, really worth looking at either the video or reading the book, which just tells us how important this is and what's all gone wrong in his lifetime. Let's move on. Circular economy indicators is the topic of our presentation. And a lot of people have tried to develop some. So we are drawing here on a 2019 review by some French researchers who reviewed 55 sets of circular economy indicators. And they said, right, let's put some order to this chaos. They developed a taxonomy, and they said, if you're looking at an indicator, you can look at these categories to see where does it fit into our worldview. So the first category is, what level does it describe? Is it micro, a single product? Is it meso, an industrial symbiosis, for example, an eco-industrial park? Is it macro, a whole city or a whole nation? Then which of the loops in circular economy does it pay attention to? Is it about recycle, or is it about reuse, or about maintaining stuff? Then the performance, is it just a mass-based indicator, so-called intrinsic indicator, which doesn't tell us anything about impact? or is it actually an impact indicator? And we'll show you one impact indicator in this presentation. Is it describing the actual situation or the potential of what could happen? What are the intended usages? Is it generic, i.e. is it all materials in a particular setting, or is it sector specific? So that's called transversality. Then the dimension is a single focus or multiple issues captured, units, format, and sources. So yeah, that's just to say circular economy indicators definitely already widely in use. So before we invent our own, we should always go and look in the literature. We'll give you some examples now of circular economy indicators that we work with, and that may be interesting in the case of plastics in South Africa. But let's start with the Microscale generic one. And this is what is called economy-wide material flow analysis. Well, that's the technique. And out of that technique, one can develop some indicators. But this takes all materials in a national economy into account. It's mass only, so it's intrinsic. And yeah, so the sort of textbook example now is the study published in 2018 by a group of Austrian researchers who described the EU 28 countries in 2014 in material flows. You've seen this, or you may not. So let's step through this very quickly. It is in units of gigatons, that's billions of metric tons, and it sums materials across 4 categories: biomass, fossil energy carriers from which plastics are derived, metal ores, and then non-metallic minerals, the kind of stuff we build our buildings with. And let's see, right, it draws a system boundary across the entire economy, and it tries to mass balance everything. And the type of diagram you're looking at is called a Sinkey diagram. So the EU in 2014 domestically mobilized 5.8 billion tons of materials through agriculture or quarrying or mining or fishing, and they imported 1.5 billion tons of materials from elsewhere. So they processed a total of 8 billion tons for domestic use or within the EU, exporting 0.6 billion tons elsewhere. And these 8 billion tons split between energetic use, which in this taxonomy includes food, feed, and conversion to electricity or uses, fuels in cars, etc., and material uses. And those material uses, again, include those that add to the stock of society, the roads, the buildings, the infrastructure, and those that are used once off and go straight through or are lost even in production. And then one arrives at the waste statistics, how much waste arises at the end of life. Some arises from the energetic uses, so the cows do poop, and so there's manures, and the people too. And the coal, when it burns, has ashes, so those are wastes that come from the energy use. And then, of course, there are the straight-through materials that become waste, and some of the stocks get demolished, and they become waste too. That waste splits into the amount that gets recycled or backfilled, 0.7 billion tons, 700 million tons in the EU in that year, and that which becomes disposed. Right, and there are some uncertainties, of course, in a lot of the measurements, but that's the art of material flow analysis. And I don't think I have to go into the details here, but the calculation balances between the waste statistics which are available and the front of life numbers that one obtains from economic statistics. And a big topic, of course, are the emissions to air and the greenhouse gas emissions. Just worth noting here, maybe in case somebody in the audience pays attention to this, this one reports tons of carbon, not tons of CO2. So the number for CO2 would be 3.4 times larger. Right, and there are the notes. Now, I took the liberty of going through that in a little bit of detail because we're busy with a study in South Africa right now that is finishing very soon, where we are doing the same kind of analysis for the base year 2017. And so we hope to release a similar diagram for South Africa in April. Here's a sneak preview of just the fossil energy carriers part, which I think we've nailed down quite well. It is very, very linear. We extract 260 million tons domestically, mainly coal. We import 21 million tons, mainly oil. We export 70 million tons, mainly coal. We burn a lot of the coal and we generate a lot of ash, almost 45 to 50 million tons of ash. And a very small portion is converted into materials and chemicals that are either added to stocks or go straight through as single-use plastics, etc. And there's some recycling, 4 million tons, and that's not just the plastics. A large portion, 2/3 of what is recycled here is actually coal ashes that are used again. So yeah, just a sneak preview, and you'll see more from us on this front. Also at the macro scale, but now sectoral to plastics, our research group did a study in 2018 at the time that the industry waste management plan was in debate. That was for the packaging industry, and so we thought we'd show what's going on with plastics in a diagram that really tries to capture circularity or not circularity. And so this has been on our website for a while. The link is down here with a little commentary, and since some people will already be familiar with it, I'm not going to spend a lot of time on this diagram. There will be variants of it in this talk, but maybe to suffice to say that we import and domestically produce polymers, which are converted into durables and short-lived materials. The durables, we don't know how much stays in use and how much went out, so we made a very simple assumption that the amount of durables from past years that becomes waste is equal to half of the durables produced in the particular year. Also, of course, work with the imports. For the waste, we have a model here of how waste is disposed in South Africa, and that is published in a South African Journal of Science in 2020 by Claire Rodseth, Pippa Notton, and myself, which pays particular attention to the 31% of households that do not have disposal. So the self-help disposal loop, we'd say 380,000 tons of plastics might be self-help disposed by households who don't have formal waste removal, right? Compared to the 11,000 tons estimated for litter, high uncertainty, but very different to the number that goes to households that don't have formal waste disposal. Collections of plastics, sorting, recycling, some trading, importing, and then back into the converters. That's the picture. So how does one go from a Sankey diagram like the one you've just seen to circular plastics economy indicators? Let's step you through how we do that. So an indicator that is widely used in South Africa, and Plastics South Africa like to use it. It's called the input recycle rate, and essentially it says how much plastic is collected for recycling relative to the short-lived plastic waste. So this is plastic that was in that particular year directed into packaging and other short-lived uses, less than a year. So that number is known, and that ratio gives us the input recycling rate. Now, some of you will know that for 2018, that number was not 40%, but 44%, and here's the explanation. So the collections actually are 484 kilotons, not 448. However, 10% of those materials collected for plastics recycling are not even plastics. And so, yeah, one can have the more optimistic 44% input recycle rate or a more realistic one at 40%. So we can argue about what we divide by what, but here's the definition then of the input recycle rate. Other countries, they use the output recycle rate. So that says, don't worry, don't pay attention that much to how much you collect for recycling, rather how much do your recyclers put back in as recyclate. And you divide it by the same number before, and then we get this number here, 29.8% as the output recycle rate. In global comparison, that is still a pretty decent number. South Africa does well in mechanical recycling. Another indicator we may want to look at is the recycling collection rate, where we take the collections and we divide it by the estimate of total plastic waste arising, not just a short-lived one. Here would also be just short of 30%. That is also now in the master plan, I think, and in the regulations from DEF and the National Waste Management Strategy, and in the Plastics Pact is the recycled content. And for the recycled content, we say how much recyclate was actually converted in the year. So in 2017, that was slightly less than what was made available. Some was bunkered, stockpiles of nice recyclates were standing around, but yeah, so this was what was actually converted, and we divided by the total amount that was converted domestically in that year. That gave us a number of 16.5% for recycled content, saying, you know, of all the stuff that was made by the converters, 16.5% was actually recycled and the rest was virgin. So there you now have a set of indicators explained. We can make ourselves dashboards of indicators. We can choose to use more optimistic or more realistic versions, and we can add other things to it. For example, the per capita plastics use in our society, which is significantly lower than in OECD countries, for example. And so it tells us that there's still unmet demand potentially out there. Just to show off a little bit, we can do this not only for plastics, we've also done it for packaging glass, which is an interesting case because packaging glass has two circularity loops. It has the returnables that are washed and cleaned and refilled, and AB InBev are the big player in this game when they're not in lockdown. So when we may go to the shebeens and those courts go back around, but there are maybe also others, and of course Coca-Cola South Africa has started playing in this with plastic as well, with the returnables reuse loop, and then there's the recycling loop where cullet is recovered from waste or from the cleaning of those returnables and prepared for recycling, goes back to the production furnaces of the glass industry. So that was a little aside. Now we come to the question of indicators that show impact rather than intrinsically just mass. So we attempted a carbon footprint of the South African plastics industry. We covered 3 life cycle stages: resin production, converting, and the end of life stage. We ignore the use stage, where the consumer may expend energy to move that plastic around, but yeah, or maybe wash it, or I don't know what, but yeah, so those are the 3 stages we've quantified, and we work with the numbers from the material flow analysis. M in this formula is the mass flow of virgin material, of converted material, and of material going to end of life, and EF is the environmental footprint, or the emission factor. So that's a kilogram CO2 per unit of polymer. And we do this across the 6 major polymer groups. So there are 2 ways we could do this. In either case, we need to have the material flow analysis. We could feed that fully into a life cycle assessment software, and then we can choose which indicators of interest we want to see. Here we would do the global warming potential only. Or as we've used it here, we use life cycle assessment to obtain emissions factors for these 3 stages and then multiply it with the quantities from the MFA. And that gives us then a carbon footprint assessment. And it's life cycle based in that our emissions factors come out of life cycle software. So we do a lot of life cycle assessment in our research group. And here it is. This is the first estimate of the carbon footprint of plastics in South Africa. It's for the year 2015. You're the first audience outside of the University of Cape Town, small seminars with researchers to see these results. And we use 2 rings here. The inner ring shows just the three stages. The majority of the impacts are associated with resin production, 14 million tons of CO2, 74% of total carbon footprint of plastics in South Africa associated with the polymers, 4.2 million tons associated with energy use by the converters. So that may well be through the electricity they buy, and emissions may ultimately lie with Eskom. And then at the end of life, 4% of total emissions. Plastics, unless you burn them, don't release CO2. And when we recycle them, we do put some energy in. Some informal disposal, 500,000 tons of CO2 estimated from burning informally of plastics, the self-help disposal option there. The outer ring breaks this up by the polymer types. So as you go around here, you see from 1 to 6 the polymer types and their contribution to resin production. So you see that LDPE and PP and HDPE, polyethylene and polypropylene, are very dominant there. And that's, of course, because they are made to a large extent from the cold to liquids and cold to chemicals processes operated here in South Africa, which are very, very carbon intensive. Then the next part just has it for the converters, where the electricity or heat used in the converting has a CO2 implication that's been quantified here. And then you see the end of life in the outer ring. So that's a novel result for you as an audience. Happy to take some questions on this one. Just maybe to alert you, some of the polymer is imported. And so for the resin production stage, 93% of the impacts are domestic, 7% occur elsewhere in the world where that other polymer is made. So this approach is for us very promising. We think it could tell us a whole lot more about the impacts that the plastics industry has and whether those impacts would change if we go towards a more circular economy as per the Plastics Pact and Master Plan targets. So we could ask, what would the carbon footprint be if we met those targets? And this is a calculation that we are busy with. So we hope to release an estimate for that later this year. We could, of course, also go and look at other impacts caused by the plastics industry, because life cycle assessment can quantify a whole lot of other indicators. Those of you who looked at the LCA study for the plastic grocery bags by the CSR, it can tell you about water use across the life cycle, about eco and human toxicity, and a whole bunch of other environmental indicators. Persistence in the environment is a big topic in LCA. It's not a good tool to tell us about persistence in the environment, but our colleagues at CSR did quite well to develop a persistence indicator for the South African context. So we'll play with that as well in our research going forward. Of course, the big question is, will circular interventions lead to lower impacts? We very much hope so, and we hope to show that with our work in the next while. Indicators are useful when you can use them towards regular updating and tracking of performance. So we have now tried to develop the Sinkey diagram for every year, for which data becomes available through the plastics recycling survey. So here's the same diagram you saw earlier for 2017, reproduced for 2018, and for 2019. It does look very, very similar, because year on year not that much changes, but if you go into the detail, do see that the numbers change, right? So recyclate 352, 353, 332 here, 338 kilotons in each case. So we have the latest numbers in there in each case. And again, to track performance in terms of indicators. So here are the 4 indicators I explained earlier. Recycled content has improved over the 3 years. Input recycling rate been a little bit, yeah, probably in the band of uncertainty, not going anywhere. Output recycling rate has improved. The collection rate has declined. And so maybe what this tells us over 3 years, that there's been a little bit less collection, but of better quality. So that's maybe the kind of story that one can get out of tracking performance. Finally, before we end this talk, we're going to jump the mesoscale. I'd also do work at the mesoscale, industrial symbiosis type work in regions or in eco-industrial parks. But we go to the microscale, which is the product level. And I want to show just some work on an indicator developed in a PhD thesis that was awarded last year to Takunda Chitaka. So Dr. Chitaka worked on a non-circularity indicator on product leakage into the marine environment. And to do this work, she spent a lot of time on the beaches, not lying around, but picking up whatever is washed up. She used a technique where she had a 100-meter stretch that she cleaned every 24 hours to see what is the ongoing accumulation on that beach environment. And so she gets an indicator of items per day per 100 meters. She covered 5 beaches in the Cape Peninsula, around Cape Town, and here are the items that really popped up a lot. This is sort of the top 10 list of things that come up a lot. So between, so for beverage bottle lids, between 7 items per day per 100 meters up to 120 lids per 100 meters every day that you go out there at Pardon Island at the time she did this particular one. So this is how you read that. For comparison, there are some that we wouldn't expect to see that often on a beach, but every now and then was found. And yeah, so beverage bottles, interestingly, were very rare. So we had 7 lids, but only 1 bottle. Here, 120 lids, but only 3 bottles per 100 meters per day. Right? Of course, bottles, those of you know the density, do sink, so they might not show up on the beach. They might have already gone under in the rivers leading to the beaches. Okay, so not to tell us, but of course we also know that bottles have a high recycling rate. Petco achieving 62 or 64% recycling of recovery of all those bottles, and therefore there's a whole lot less going into the environment in the first place. Whereas lids, well, maybe they are on the bottle when it's recycled, and maybe not. A lot of people just toss it and it goes down that stormwater drain. Okay, so yeah, just for comparison, then these are raw sort of kind of indicators. What I then did was to obtain sales figures where possible and to ratio a scale up of the entire Cape coastline, theoretically, to the entire sales in the Cape Metropole. And that gives her very roughly some indicators of what percentage of what was sold might be reporting into the marine environment, right? And so for beverage bottle lids, 83% might actually just go straight through to the marine environment. A big standard error there. Very low for cigarette butts, and again, those might not make it all the way through, or the smokers have started to behave better, or a lot get smoked indoors and actually put into bins. Don't know, not my game. Lollipop sticks, lollipop wrappers, that's the numbers. Straws, much debated. So yeah, again, in the tens of percent might report to the marine environment. Single sweet wrappers, no sales data available. Snack packets, and she's got some very interesting photographs in her publications there of whose brands those are. By comparison, again, the beverage bottles, about 5% seen on the beaches, not to say where some of the other 33% that aren't recycled end up, probably underwater. And by comparison, these other items in the single digits, right? So we have indicators here that distinguish at the product level of non-circularity and particularly about this concern accumulation in the environment. And this is my own photograph of the so-called estuary of the Salt River. Note the concrete and note all the garbage that comes down there. And people who do cleanups know very, very well that the river transport is a big issue. And this is then our conclusion, the last slide. So what does all this mean? Let's go firstly to a wrap up, the conclusion. So what I told you in this talk, circular plastics economy should fit into sustainable development ambitions. It's not a standalone concern. There are already many indicators. There's already a taxonomy. So if you're going to use circular plastics economy indicators, choose carefully. We have demonstrated some indicators in the South African context. I've shown some for the whole economy, for the plastic sector. We've shown how we can do yearly updates. We've even gone to micro level indicators. We've asked the question, what does that tell us about impacts? We've attempted to quantify the carbon footprint of the industry, and this is work in progress. Therefore, as it becomes more circular, will it go down? By how much? How fast? And of course, the littering and the persistence indicator needs some work, and there may be other indicators that get other people hot under the collar, be they environmental or socioeconomic, such as conditions of work of the people who do all the recycling. And our approach, our technique, we've told you, is to couple material flow analysis to life cycle analysis. And that's what we do. We are a research group that does energy and industrial systems analysis. Here is our homepage. And yeah, thanks very much to Safripol for giving us the opportunity, I have to say it, to blow our vuvuzela. This is your slide, but I really like it. So thank you very much. And credits definitely to the postgraduate students who have contributed their research into this presentation. Dr. Takunda Chitaka was mentioned, Claire Rodseth for her work on plastics end of life from a life cycle perspective. Claire now works at a major brand owner in the sustainability department doing life cycle assessments in the UK. Sally Berger, who's busy with a master's, interestingly in construction and demolition waste. But she identified that piece of research on the taxonomy. Tahira Goga, my co-author for this set of slides, this presentation, whose PhD is so central to what we're showing here. And then also Dr. Valentina Russo, who was a postdoc with our research group for 5 years, and some of the underlying data that we're drawing on, which are now internationally published around the carbon footprints, the life cycle indicators for plastics. That was work that Valentina and I did together. So thank you very much to you as an audience. And in case you had to listen to this pre-recorded version or you listen to it at another stage and you have questions, please turn to the organizers. Otherwise, please just Google for me. I've got a Google proof name and contact me for questions. I'm Harro from Blottnitz, professor at the University of Cape Town, Department of Chemical Engineering. Thank you very much.